Firecast, a podcast from MDM Publishing, brought to you in association with International Fire Protection Magazine, the global voice for passive and active fire protection.
Welcome to another Firecast, where we get to discuss some of the key issues with the big players in the fire industry. I'm Paul Hutton. Today on the Firecast, we're going to be talking about a new alternative for liquid level measurement in gaseous fire suppression systems. Joining me and MDM Publishing's group editor Duncan White is my guest Patrick Schwobe, Principal Engineer of Advanced Product Development at TLX Technologies. And we're going to find out about the new liquid level sensor for measuring and monitoring extinguishing agent levels in fire suppression systems. While there are currently several methods on the market for measuring agent levels, these methods require technicians to interpret and convert measurements in order to calculate the level of suppressive agent in the system's storage tanks. TLX Technologies saw an opportunity to improve the accuracy and robustness of the overall fire suppression system by developing a new solution for reading extinguishing agent levels either on-site or remotely without the need for technicians to interpret and convert the measurements. So let's find out with Patrick what this is all about. Patrick, welcome to the Firecast.
How you doing, Paul?
Thank you very much for your time today. So, accurate and timely data collection on extinguishing agent levels in system tanks is critical for the proper operation of gas fire suppression systems. As I mentioned in my introduction, there are already several methods on the market for achieving this. So could you discuss some of these methods for measuring the extinguishing agent?
Yes, absolutely. We're aware there are several different current devices out there and current methods for measuring the levels of the clean agents in these systems. I guess first, and one of the more popular ones, is a dip tape type measuring system. Basically, what it's similar to is checking the oil level in your car. So, there's a sealed tube that protrudes down into the clean agent tank itself, and there's a magnetic float that rides on the outside of this tube in the tank, in the agent. There's basically a stainless steel tape measure that drops down and magnetically interlocks with this float, which the technician can then, by feel, get a measurement. So, again, one of the challenges with that system is there is human, interpretation of that feel. So I'm going to say the repeatability of that measurement technique, although it does meet specifications, there may be some room for improvement there. One of the other, methods that's used currently in the market is ultrasonic measuring with an ultrasonic probe or sensor. In this fashion, the technician would basically take that ultrasonic probe after calibrating it, place it up against the side of the tank, and basically move it up and down in order to find the level of the liquid itself. This still does require, after that level is located, a physical measurement of the height, which the technician still has to go back and, interpret a lookup table, which again does have potential for error, which could lead to an unreliable value. One of the last methods that we're aware of, and maybe one of the more accurate, is actually physically weighing the tank. So the tank itself, there's a variety of tank sizes, weights, or sizes that the tanks can be. One of the difficulties is weighing larger tanks. So there's a safety aspect that the technician needs to be aware of, in addition to potentially temporarily disabling the actual fire protection system by taking that tank offline to take that measurement. Each one of these current systems does have pros and cons, but we did see an opportunity to improve upon all of them with the device that we came up with.
You've outlined several usable options. They all meet regulatory standards. So why did you think that there was a need for another liquid level measurement product?
According to UL 2166 and FM 5600, both of those specifications require a liquid level indicator really to accurately indicate the quantity of clean agent of that storage tank to within a tolerance of plus or minus 2.5%. Those other methods do meet that requirement as they're used currently in the market, but we identified a setup that utilized a sensor that had, I'm going to say, better resolution, down to plus or minus 1 millimeter, which allowed for that accuracy the accuracy that we could attain to be better. I guess the other opportunity we saw with our device is the measurements themselves are affected by temperature. So depending upon if the agent itself is, say, at minimum specified system temperature or maximum, the actual liquid level height measurement itself will vary. So we had the ability to basically build temperature compensation into the sensor itself. So it basically simplified the measurement process and pull that human error aspect out of that measurement.
Well, there are some of the challenges. Before we get on to your solution, are there any other challenges? I just really want to understand and set the scene for the present situation and why your solution is needed.
Currently, the systems are inspected in a semi-annual maintenance inspection process. The only time these tanks are actually checked for level to verify that, in the event of a fire, that they would work properly is only done twice a year. With our solution, and based on the customer requirements input, we can basically increase that sampling rate to once a day, once every 2 days. So you have the ability to really make sure that system is ready to put out a fire when needed and not just checking it every 6 months.
That is incredible. And actually, while this is a podcast, we're on Zoom, so I can see you and you can see me, Patrick, and I can also see Duncan White, group editor of MDM Publishing, who his mic was muted, but I saw him gasp when you said that this could be done once a day. Duncan, let's bring you in because I'm sure you've got a couple of questions to ask Patrick about all this.
Yeah, thanks, Paul. Patrick, I was very interested listening to what you had to say there. I was aware of some of the systems currently on the market and was also aware of the issue of the need for human action in carrying out some of the tasks. The bit that's always concerned me is the issue of having to disable the system whilst the measurements are carried out. And I think that anything that we can bring into the marketplace that takes away that potential for human error is only going to be a positive step for life safety going forward. I wonder if you could tell me how TLX liquid level sensor works and what makes it different from what's currently out there.
The system itself, I'm going to say the hardware of our sensor is similar in fashion to the dip tape type sensor. There's a sealed tube that goes down into the tank that obviously is part of that pressure vessel. And that actual tube and how it fits into the tank can be customized. So it actually can fit into any existing tank or port size. There is still a float that rides on the external of that brass tube that does include a magnet. But where our system starts to differ is there is an internal float in the tube that basically follows the movement of the external float. So as the liquid level would go up or down, moving the external float, the internal float will follow that movement up or down. Now, what we use is a sensor that can determine the distance between basically the top of the tank and the top of that internal float. So as that fluid moves up and down, moving the external float, which moves the internal float, we're watching that distance. That distance, that data is captured. The temperature data is captured. And what we can do with that is, based on an empirically derived lookup table for that specific tank and agent, compare that data and basically output the weight of the tank, which then can be compared against the most recent value to determine if that tank, make sure that it's not leaking or dropping down. That's kind of the mechanical portion of it. How the sensor itself actually interfaces to a customer's system or panel. Now that actually can be customer specific. So if they want to hardwire something back to the panel just to indicate that, hey, my level dropped below the 2.5 or 5% that we were allowing, there can be a signal sent saying, hey, this needs attention. If the system is put together and designed to communicate through Wi-Fi or Bluetooth or some other wireless communication, again, that data can be collected on a higher sampling rate, and as soon as it hits some set level, a signal can be sent and the customer can be notified immediately.
You mentioned that the product addresses the need for monitoring levels remotely. This is hugely interesting. What communication options will this new liquid level sensor have for the customer?
I guess, as I mentioned, the device has the ability to be communicate through a wired signal or multiple different wireless protocols. We've looked at, Bluetooth, Wi-Fi, LoRa communication. So, I mean, really that portion is customized and can be customized to the specific customer requirements. A customer may be set up to be able to take that continuous data through a Bluetooth or Wi-Fi communication, or the customer may just be interested in knowing that the semi-annual maintenance inspections are done. So at that point, the unit can be designed that there's still a maintenance personnel there that basically presses a button, that data is captured. It can be stored locally on the device on some non-volatile memory, and can always be, I guess, reviewed at a later date through just a USB or micro USB connection, which, you could plug into your computer, or even it could be locally Bluetooth communicated to a tablet or an iPhone or something.
So there's a number of options. So one of the things that just springs to mind, so a system on board on a ship. So the ship's company can remotely monitor it from on board, but this information can also be monitored from the home port of the ship to make sure that everything is working as it should be. Yeah,
the way I see that working is our device would communicate with a central control panel, and that control panel could be accessed, via Wi-Fi communication. Basically, at that point, it's the portal, it's on the web, and probably, it has the ability to be reviewed or viewed anywhere in the world.
So we've got a backup system that can, for peace of mind for the people that are in the middle of the ocean, worrying whether they've got the correct level of protection for their fire system.
Yes, it definitely could be configured for that.
Thanks, Duncan. I'm going to butt in again now, if I may, Patrick, because it sounds to me like TLX Technologies have got a solution for capturing and storing the data from the sensor in whatever way the customer actually needs it.
Yes, absolutely. I mean, that data and how that data is distributed or stored really is customized per each individual customer specifications. So, I mean, we have the ability to send that signal either through wired communication back to a control panel, or through a variety of wireless communication protocols that, include Bluetooth, Wi-Fi, or even LoRa communication. In the event that a customer is interested in specifically just storing the data on the device, verifying that the semi-annual maintenance inspections are completed, we can do that as well, where the device, just stores the data on non-volatile memory, puts a date stamp on it, allowing at some point that data can be reviewed. That data can be pulled off through a USB, micro USB connection, whatever the customer desires.
Yeah. So basically what you're saying there, Patrick, is that the system is totally bespoke and the customer can really have whatever they wish. So now my question is this liquid level sensor able to be added to systems already installed?
So I guess since the liquid level sensor is part of the pressure vessel, it can only be installed when the tank is not pressurized. So typically this installation is done when the tank itself is filled during initial fill. But if the tanks are ever emptied or out for maintenance, or anytime that they're depressurized, the ability to install that into that tank would be there. The liquid level itself can be customized to fit all different heights of tanks, diameters of tanks, port sizes. So that can be customized per specific requirements. This device is primarily developed to work with clean agent systems, primarily Novec 1230 and FM 200. And, these clean agent systems are typically used in areas where water does more damage than good. So, I mean, computer systems, server rooms, museums, historical buildings, areas where like flammable liquid storage and water really wouldn't supply acceptable coverage. I guess moving things toward the Internet of Things, where that real-time data can be captured and the health of the fire protection system is pretty much always viewable and accessible, and you're not you're not guessing if the system is still fully functional.
Patrick, that was fascinating. I think having spent much of my working life in the industry, it's great to see that technology and innovation is still playing a huge part here, and that there's companies like TLX out there that are pushing the boundaries to make fire suppression systems and life safety systems as safe as they possibly can be, taking out that potential for human interaction to forget to put the system back online properly. And we applaud the work that TLX does, and look forward to catching up with you all again soon to see what the next product is that you bring to the market. Thanks very much.
Absolutely.
Okay, so how do you get a TLX liquid level sensor spec'd into your fire suppression system?
Yeah, I guess in order to get the liquid level spec'd into your system, the end customer would want to, I guess, work with their system supplier to get that put into their system working with TLX.
Patrick Schwobe is Principal Engineer of Advanced Product Development at TLX Technologies. Now, TLX Technologies is interested in working with customers to develop the solutions they need for their current and future systems. Now is a great time to get a jump on the market. You can contact TLX today at firesuppression@tlxtech.com to ask questions or to discuss your next project. They are here to help. Thank you, Patrick, for such a great insight. And as always, thank you, Duncan, for your thoughts on a fascinating and enlightening discussion. And thank you for listening. That's it for today's Firecast. We'll talk again soon.
Firecast is produced and presented by Paul Hutton and is an MDM Publishing podcast in association with International Fire Protection Magazine.